Normal distributions. Super exciting. Yes. So, anyways, we talked about yesterday about the normal distribution. It looks like this. There's the mu or the mean or the average is what everything is based off of. Okay, so that's always in the middle. And then this weird little sign is your standard deviation of how far out you go. Okay. So I said before this is mostly the chart you want to keep going back to. So hopefully you have this handy. From here on out though, so when you do the next video, it'll be calculator use. So you just have to kind of have an idea of what this looks like. We did all this. All right, we are here. This is where we got stopped, I do believe. So what's the probability that a woman's pregnancy will be between 261 and 303 days? All right, I started writing this a slightly different way, which I think will be more helpful, but I will do the way we did it before with the picture on this one, and then I will switch over to the other way. Okay. Oh, we have, I'm actually going to switch over right now because sometimes this picture is kind of crazy. We have 275 in the middle. All right, if we go out one standard deviation on each side, we're going to add that 14 days, correct? So we will be out to 289. That's one standard deviation. I'm not quite to 303 yet though, so I have to go out one more standard deviation. What color did we do second? I'm trying to stick with it. Red. Okay. So if we went out one more, now we would be at 303. And if we went the other way, one standard deviation, now we're going to subtract on this side, so this would be 261. Okay, so the green is one standard deviation, the red is 3. This is what I'm looking for. Now when I draw my lovely little thing, this is that middle, right? So then I'll kind of go like this. I'll go out like that. That will be my 1. This is my mu. That's my 1, and there's my 2. Okay, so this is the area that I'm looking for. Okay, so when you're looking at it, you want the middle part, which is, well, actually, we'll put these in 3 different things. So this little section right here, this is the green. This is 34.1. This is 34.1. So together they make 68.2. And then that going out to this next one would be 13.6. And then we're going to add these all up, and we would get a total of 81.8%. That is what the probability would be. Okay, so it's just kind of like the area under that curve. Next one, what's the probability a woman's pregnancy will be longer than 275 days? So 275 is that mean that we have, and they want everything that's larger than that. If you think about this, if you draw the little thing, that's that mu. We want everything over here, so that'll be 50%. That's half of the data. Okay, you guys were supposed to try this one. A continuous random variable x is known to be normally distributed with a mean of 15 and a standard deviation of 5. Find the range between which approximately 68% of the values lie. Okay, this one is you're visually thinking about what's happening. So 68%, if you were to draw your picture, if you go back to where we were before, that's going to be like this, right? So that is one standard deviation. So that's where 68% of them lie, okay? And the next one says 95%. Okay, so 95% is going to be 2 standard deviations. So we got 1, we have 2, we got 1, we have 2. Goes out to that. That is 95. So within 2 standard deviations. And then we're going to go back and actually answer this question because we haven't answered it yet. Right now we're just kind of talking about what's happening. And then I'll go back and actually do like the numbers. Okay, so then the last one says 99.7. You like how my heels are getting quite shorter and, a little bit chubbier. I don't know what's going on with that. I apologize. Okay, then this one goes out to 3. Okay, so we have our mean. 1, 2, 3, 1, 2, 3. Alright, so this is going to be 3. The reason I did this is because we're now going to go back and write down these values. The mean is 15. Okay, so the 15 goes here. Now there's a standard deviation of 5. So if I go plus 1, I'm going to be at 20. If I go another plus 1, so this is plus 1 standard deviation. If I go out another, I have to add another 5, so now I'm at 25, so that's plus 2. If I go out one more, I'll be at 30, and that'll be plus 3. Okay, then I can go the other way though, and I can go backwards 1, and I will be at 10. Do another one, and I'll be at 5. Do another one, and I'll be at 0. So this is minus 1, this one's minus 2, this one's minus 3. So this first one says within 2 standard deviations, with 1. So that's 15, so my range of numbers then would have to be 10 to 20. Okay, because it's got to be within 1 standard deviation. The second one says within 2, so I had to go 2 out to 2 forwards. Okay, so then I'm going to be between 5 and 25. And finally, that last one is 3 standard deviations. So I'm going the whole gamut on this one. So this would be 0 to 30. Okay, that would be the range of numbers. So the ones I circled are actually what you're wanting. The pictures just kind of help us visualize what's going on. Okay, a normal probability density function x has a mean of 24 and a standard deviation of 7. Find the approximate values of these other things. Okay, so I'm going to sort of do the same thing that we did before. I think this is easier for me to look at. 24 is where everything is based off of, right? Because that's that mu. Then I'm going to go out a few different ones. I'm going to go out 1 standard deviation, so I'm going to add 7 to this. So I'm going to get 31. I'm going to add again, I'm going to get 38. I'm going to go out to 45. Okay, now you're going to do the same thing the opposite way. 17, 10, and 3. Again, remember, this is plus 1. This will be plus 2 standard deviations either way. And this will be 3 standard deviations. Okay, so green is 1, red is 2, blue is 3. It seems to be the pattern we're looking at. All right. Now when we come down and look at this, now we'll draw a picture and figure out what the answer is. Okay, so I want x to be less than 31. Okay, so now I'm going to draw this so we have an idea. So we got 24, and it looks like 31, we already have it, is within 1 standard deviation. So we're looking just for that tiny little sliver right there. Okay, so, oh, sorry, it's less than that. So we got the tiny sliver, then we got to go down this way. So that whole other section, this section right here, this will be 50%, right? Because that's half of it. And then we still have to add that one other little chunk right here. And this is going to be 34.1. So in the end, we're going to end up with 84.1%. Now for drawing the next one, we still have 24. Now we have to go out to 31, and we're going to go back to 10. Okay, so, oops. On this side, the 31 is like that 1 standard deviation, right? And then it looks like on the other one, we went out to 3, so it's that section as well. So you got to figure out what you're going to add onto it. I am going to take this one little piece that goes this one. That piece is 13.6. And this whole middle section, which is the 1 standard deviation, we remember that is 68.2. So when I add these two together, I'm going to get 81.8%. Okay, now the next question, it would be different if we were doing binomial, but the nice thing is when you are dealing with normal distribution, it doesn't change. Okay, so when we look at this, we have the whole area within 1 standard deviation plus the other one, which is the same as this, right? These are the exact same thing, though this is also 81.8. It doesn't matter since they're continuous values, and a line can't really be anything. It can't actually equal it, right? It doesn't actually have a thickness. So these are going to be exactly the same. So anytime you see less than or equal to signs, don't worry about them anymore. Okay, now we have the last one. We need the probability that x is greater than 10 given that x is less than or equal to 30. Okay, so this one, let's draw a picture because I feel like this is going to help us the most. This is still 24. I gotta go out to 31. Alright, so now it says that it's given this. I'm going to try this way instead. So I know that all of this is there. So I don't have anything that's above 31. Okay, so this is my given. Now I have to find out the probability that x is greater than 10. So x is greater than 10. Oh, first, that's that. X is greater than 10, we will do in green. Okay. 10 goes out to 2 standard deviations this way. So there's 10. Okay, so you're looking for the green part is what you want, and it's part of the purple. So it's the green over the purple. Green goes on the top. And if you notice, we don't actually, since we know that x has to be less than 31, you can't include anything above it. All right? So we have to do 81. So it's these two parts that we have right here. That's going to be that one that we're looking for because it's between 10 and 31 because it's given that it has to be less than 31. So this will be 81.8 divided by that little purple part that we highlighted, which is this whole first one. So this will be 84.1. And then when we divide it, we get 97.3%. All right, we got a few more. The number of pears harvested from each tree in a large orchard is normally distributed with a mean of 230 and a standard deviation of 25. Find the approximate probability the number of pears harvested from a randomly selected tree is. Okay, so 230. I'm going to go out 1 and I'm going to get 255. Go out 2 and I'm going to get 280. Do the same thing this way. Subtract 25. I'm going to subtract 25 once again. Okay, so this is plus 1. This is plus 2, minus 1, minus 2. Okay, so those minus and pluses, you guys, are based off of how many standard deviations you went out from the mean of 230. Okay, so less than 280. Now I see that that is 2 standard deviations away, so that's 280. So we want all of that area to be shaded in. Okay, so we need 50% that goes up to mu, and then I need to add the standard deviation, the first one, which is 34.1, plus the next little one, which is going to give us 13.6. So if we look at this, 50% is all of that. Okay. 34.1% is that little sliver. And the last one is 13. That's that last little part. Okay, I have to add up all of those areas to get the total, which is going to be 97.7%. Did anybody see another way that I could have done it? I could have also done 100% minus that area right there, which would be 2.15 minus 0.15, and you get the same answer. So if you see it the subtraction way, go ahead and do it. Okay, between 180 and 280. Okay, 180 and 280. So there's the mean. 180 is 2 this way, 280 is 2 that way. That's just out 2 standard deviations, which is kind of nice because that's just 95.4%. Okay, is greater than 180, okay, given that it was less than 280 pears were harvested. So if we draw this, 230, there's your 180. Has to be greater than that, given that less than 280. So there's 280. So this first part is greater than 180. Alright, and then it says that it is given that less than 280 was there. Okay. So if we did less than 280, we did that in the beginning. That was 97.7. Okay, that's that top part. And then between 180 and 280 is what we're looking for, that's going to be this overlapping section. So that'll be 95.4. We'll go there, and then we will divide it, and we will have 97.6%. So be careful when you guys are given those givens. There's two parts and you have to divide it. When you guys were taking your quiz, a lot of you guys forgot about the given. There was like an exact number, but you forgot you had to divide it by another part. So remember, there's always a few parts when there's a given in the situation. All right, the annual rainfall in a particular area of Australia, X millimeters, is known to be normally distributed with a mean of 305 millimeters and a standard deviation of 50 millimeters. Okay, so we have to calculate the probability that the rainfall is between 205 and 355. Okay, so let's do that same thing we did before. I'm going to do it at the bottom this time so we can kind of look at it. These numbers are a little bit bigger. So 305 is that mean. Okay, so if I go out the standard deviation of 50, I'll be at 355, and I'll be at 405, and I'll be at 455. Okay, you can also go the other way and subtract 255, 205, and 155. So this is plus 1, plus 2, plus 3, minus 1, minus 2, minus 3. Okay, so those are standard deviations. So calculate the approximate value of the probability between 205 and 355. So 205 and 355. So if we draw this to try to get a picture in our head, 205 is 2 out, 355 is 1. So we're looking for this. Okay, so we need that one area, which will give us 13.6, plus this is the standard deviation within one standard deviation, and that's always going to be 68.2, so 81.8%. Okay, now it says, find k such that the x is less than k, the probability is 0.025. Alright, so 0.025, you guys, is, if you look back up here, where's that picture? It's so far away. It's this whole thing up here. Do you see this? So we got to put this little thing up. It's going to be everything that's less than 1 and 2. So this is 1 standard deviation, 2 standard deviations. This third, remember that area was 22.15, and this tight little one here is 0.15. So if I add those up, I have about that. So I have to go out 2 standard deviations. So k will equal 205. Okay, because this is the 2 standard deviations. Find h such that when x is less than h, the probability is 0.015. Okay, so that's that tiny, tiny, tiny little piece on the end. So h will be 155. All right, so that's the last part of these ones. And then the next one you get to use a calculator, which I think will be kind of nice. And you don't have to try to picture what's the question's asking in your head, because that can be really tricky. All right, well, I hope you guys are having a lovely day, and I will see you all later in another video. Okay,